Hello, hello. Good evening, everyone.
Yeah, you are doing.
Good evening, sir.
Good evening, sir.
My voice is, my PPT is slide is visible,
Yes, yes, visible, sir.
and voice is clear or not?
Voice is clear.
So can we start? I think 63 student already join, or we should wait for 5 minutes for other.
Good evening, sir.
Good evening. Should we wait for other people, or can we? Can I start?
Start, sir.
So you should start. So it's already 7:10.
Yeah. So I am Ashok Kumar, and I am a PMRF scholar and pursuing my PhD from Indian Institute of Technology, Jodhpur. And I will take your live session in every Tuesday from 7 to 8 p.m. of fiber optics communication technology, in which I will solve your assignment doubt and other theoretical doubt you can post in the chat box, or you can raise your hand. There is any option in that Google Meet. You can raise your hand, so you can unmute, and you can also ask to me your questions, your doubt, and if you have any doubt in any assignment or quiz, you can ask me in the chat box, so I can answer your maybe help you in to solve out that questions. Also in theory class, if you have any doubt regarding that content or anything you have doubt in the theory class, you can write in the chat box, so I can forward it to the that coordinator, that Professor Deepa, for your more clarification, and if from my side possible, I will solve it. So everyone understand that?
Yes, sir.
So if you have any doubt till now in any class, you can ask me first, and then we go to for the assignment. Till
Sir,
now,
I just want to understand the mechanism of fiber.
only fiber. Hello, Pooja, it is you, Pooja. Hello,
Sir, it's Namita
Namita.
this side. Yes,
Okay.
sir. Sir, I just want to know about fiber brag grating mechanism.
Okay, so I think that will not, maybe some small part will be teach you in that class, taught you in the class.
Yes, yes, sir. Yes, sir. Yes, sir.
In next after 3 to 4 lecture, there is a one separate chapter of that optical component, and whatever the functioning of that optical component. I can basically
Ashok,
I can give you idea about the fiber optical fiber grating.
Okay, sir.
Ashok, may I interject?
Yeah.
Uh, Hi, I'm Jonak. I'm the other TA, by the way. I'm looking at the technical side, actually.
Yes. 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 Tell me.
Anyway,
Yes.
so because this is a technology course,
Okay.
fiber bread gratings use will be covered, but
Ye-
the actual Maxwell's equation, what uh, we use perturbation theory to find out this
So,
fiber
so
bread
no, I
gratings
don't.
working,
I'm not
right? So
asking about Maxwell equation. I just want to know the basic
He
mechanism.
just know that what is
yeah,
the
you will
how
be
to.
able to use it.
Yes.
So
Yes.
after this course, you will be able to use the fiber break grating, and we will be covering it in maybe
Sixth or seventh
in a
maybe.
ray picture.
Yeah.
Yeah, as a ray picture, we'll be covering it, but in-depth theory won't be covered in this course.
Okay, sir.
For basically what is the fiber grade getting, it is the segment of the fiber. Okay.
Okay.
For your knowledge basic, it is a, like the there is a channel of the fiber in which it will select on a particular wavelength of the light only.
Okay.
So if you want to like that, your visible region is from 400 to 700 nanometer, and you want to select like the 600 nanometer, then you that fiber grating will be help you to select that wavelength of light. So fiber grating role is to select the particular wavelength of the light only, in which we use the fiber grating of in the optical communication. So if you have
Okay,
the
sir.
full source of that light, and if you want to select only particular wavelength, then you select that particular grating of that break grating through which you can select that 600 nanometer only.
Okay, sir. I got
Okay.
it. Yes, sir. Yes, sir.
Any other? You can also put your doubt in the chat box also. I will read your message on chat box also. If you have any doubt in the first class chapter first, you can ask here, and then we go for the assignment. Or I will ask some basic question to you, so you will be respond to it. Is interaction interactive class between me and you, because you are not able to interact with that Professor Deepa every time, so you can ask, we can interact here. You can ask me any doubt or problem regarding the class lecture, you can ask me here only. So after that I will forward to the course tutor, and he will reply to during the class also, or as well I will also reply in the next class. So everyone should be participant here actively. So more benefit of this, you can learn more things about optical fiber communication technology, and how the course is going on, and what is the new technology will become in the optical fiber. So I need your actively participate in this course. Guys, can you put your doubt in the chat box? Then I will start the assignment.
Actually, we can move on, I guess.
Yeah, yeah. I just read that assignment, the doubt in the class. After that, I will.
So the assignment submission date for both the assignments are 10th of August, no?
Yes, yes.
Yeah, yeah, you have one more week for the first assignment. After that, it will go on like every Wednesday. And before the submission, like one night before, we will have this session. Like if
But
you have any
we can
doubts,
submit for like both the assignments. We have a date of 10th of August, so we can submit it before that.
Yeah,
yeah,
yes,
yeah, yeah.
yes. Before then, you can submit before 10th also.
Okay,
But
sir.
after 10th, it is not possible. Last date is
Okay.
10th is 10th.
That means okay, sir. Thank you so much.
Okay.
Okay,
So,
sir.
uh, I have go through the assignment one, in which there is you mention the 5 questions. So first question is for complex modulation system with symbol rate of the 5 gigabit using 16 QM modulation format. What is the effective bit rate? So can anyone know me that what is the difference between the baud rate and bit rate? If you go through the lectures and what is the bit rate and baud rate, can you give, provide me a difference of that? Anyone can raise the hand and speak that, or what is the why we are go for the digital modulation or analog modulation? If you understand the basic of analog and digital modulation, any advantage disadvantage you can. I need your participate in this like live sessions. Otherwise, it is difficult for me also and for you also. If you not ask a doubt or not participate, then not possible. Okay. So someone asked me the consolation diagram. So this is the 16 quadrature amplitude modulation. So in this we have changed the amplitude of the signal, like we have like signal like that. Okay, this is the our modulation like that 1 0 1 0 waveform. In digital we have assigned that 1 0 1 bit only. Okay, in analog the signal will be like that, only sinusoidal waveform or cosine waveform like that we have. But in digital communication we convert that analog signal into digital form, and either we have assigned that like positive signal to either 1 or G, it depend upon you, 0. If you assign that 5 plus 5 volt equal to 1, then it is one sign bit, or if you assign a negative bit 0, then it is 0 bit. You can reciprocal these things also per your convenient. Okay, so from so quadrature amplitude modulation, in which we have to do the amplitude shifting. So quadrature means 4 shifting, 4 bit shifting. So it in consolation diagram you see that there is a bit mapping of the 16 cube. So there is a 4 bit. If you a signal, you combine 4 bit into one signal only. Okay, so these are x y and x y in x y graph we have to plot all the signal in the consolation diagram, and ma'am also explained that si 1 equal to 0 j 0 plus 1 j plus 0, like that 1 1 you have to assign like that. Ma'am also explained in that lecture also that how to you how do you define that 1 and 0 bit in a signal form. So this is the comparison of the all the modulation BPSK, QPSK, 8PSK, 16 QMA, 32 QMA and 64 QMA. BPSK is the binary phase shifting key. coordination phase shifting in which we binary means we shift only the binary signal, मतलब कि two signal only. So it bits per symbol rate is only one. Okay, so symbol rate and baud rate is equal to same. Bit rate in which we define the how much the bit will be transmitted per second, and in the baud rate we have defined that how much the signal complete signal will be transferred per second, complete sample signal, like that. It 101 is a complete sample, so how much the sample it will take time to transmit per 1 second. But in the bit rate we transfer only one bit, how much one bit will be transfer in per second, it is the difference between that. So in QPSK we have the bit per symbol, we take the two symbol. 8 PSK we have take 3, 16 QM we have take 4, and 32 QM we have take 5. It will define like that, it is 2 की power n. Okay, so this bits per symbol is the n is equal to bit per symbol. So if the bit per symbol is 5, then your coordination amplitude is 32 km. Okay, so we have in the 16 qm how much symbol we bit 4 bit per symbol. Okay, so we send 4 bit per single per second. So your effective bit rate equal to, so bit rate equal to baud rate into number of the bits per baud, how much the number of signal will be transferred. So in this example you given the symbol bit rate equal to 5 gigabits and you given the 16 qm amplitude modulation. So from this you can calculate how much bit per symbol equal to 4. So your baud rate equal to 5 gigabits and number of bits per baud equal to 4. So if you multiply both the things, you multiply 5 gigabits into 4, then it will come equal to 24 gigabit per second. So it is your bit rate. Okay, anyone have any doubt in these questions, can you ask me, or I will go forward. Jonak, if I am somewhere in the wrong, please clear it.
Yeah.
Okay.
Yeah.
So this is all about that. Someone asked in the chat box that bit sequence mapping of 60 qm and 16 qm consolidation diagram. So we have to, like that in BPSK we have only one signal we have to multiply this type. But in the 16 qm we have assigned the 4 symbol in one diagram. So this is the 4 symbol like 1 0 1 0. So we have assigned that 101 in that positive x direction only. In positive x or positive y you take I or q, whatever the your convenient it will take as per the diagram. Okay, so in quadrature amplitude modulation provides some significant bit of data transmission. It will take less time because we can combine the 4 bit and it will transmit at high speed and take less time. So in 16 qm transmit like 64 qm transmit, these are the all the coordination amplitude modulation. We can transmit 60 qm, 64, 126 qm, 128 qm. So next question is which of the following statement or are incorrect? I need your answer from your side. So anyone can answer one by one about these things. Which of the statement incorrect and why? I have already provided the answer C and D. So I need a justification from your side. Guys, please unmute yourself. What if you are wrong, then it's okay for me, but you have to answer that. You have to actively participate in this. If someone is wrong,
from the option we can eliminate the wrong one. So if you see the answer B, option B, all the natural signals are analog in nature. Obviously it will be in the sinusoidal format, so which is an analog one. So we can eliminate that one. And option A, digital communication requires more processing than analog, because we have to convert the analog signal into digital by using this quantization method, sampling and quantization.
Yes.
So
you are correct.
obviously, comparing to the analog signal, digital communication requires more processing.
Okay, and why C and D are wrong incorrectly?
One sec, sir. I'm just go through it.
Sir,
Because as you said, bit rate and relationship between your bit rate and baud rate. So in QPSK modulation, so we can combine the bits according to our wish. So obviously our bit rate will be less than the baud rate.
No, in this he has a QPSK bit rate is always greater than or equal to bit rate. Like bit rate is the
Yes, it is.
sample. Bit rate is the sample per second. Whatever the sample you say, and bit rate is the bit per second. One bit, how much one bit will take time to transfer from one signal rate. So you already I have previously provided a formula na bit rate equal to bit rate into bits per second symbol.
Yes, sir.
Last
Yes.
question. So it will not be equal.
Yes, sir.
So it will be wrong. It will be wrong. In that case, it is incorrect. And last one, can we answer anyone that FSK is widely used in optical communication? It is correct or incorrect?
It is incorrect because PSK is widely used in optical communication.
Why PSK? In optical communication, we have used optical modulation scheme like that OON. You have read in a ma'am OON. Jonak, I am correct? Jonak?
Yeah.
So we cannot use this digital modulation. We can after like that if we have the analog signal like that. This is our analog signal. We have the convert into the like that modulation and demodulation. We have to convert into digital like that sampling and quantization through that. Like that non-return to zero waveform, return to zero waveform. In this format, whatever the format, we can transfer this analog signal into digital signal. If we want to transfer this signal through the optical fiber, this will not transfer through the optical fiber. This is not compatible with the optical fiber. We need to encode or decode into the optical format. So we need another modulation. So I like that optical domain which are compatible with the optical domain. So we cannot use like FSK, PSK, QAMA, BPSK. We cannot directly transfer through the optical fiber. We need the optical modulation for that only. Okay.
So basically, on-off keying is very popular.
Yeah.
Nowadays we are moving towards this QAM and things, but you will see in the course that they require like expensive equipment, like
Yes.
one Maxender modulator might break just due to electrostatic discharge. Like they are delicate instruments. So even nowadays, whatever the BSNL and these guys are using, they prefer on-off keying. The speeds are not like as much, but because we'll see in the course, like we'll be using wavelength division multiplexing.
No, no. If
We
we,
won't be
Jonak, I think
we
that if
won't be
we
changing the
digital
frequency.
communication, digital signal we cannot directly send through optical fiber.
Yeah, so like we don't like shifting frequencies,
Yes, yes,
but we can multiplex multiple frequencies. That is okay.
yes,
You'll
yes,
see in the course. It's
yes,
later in
yes.
the course.
Sir,
So
I have one question.
yes,
So, what is the basic difference between modulation format and modulation technique? Like this
modulation.
on-off
Yes,
format, like
yeah,
on-off king, it is a modulation format.
yes,
If I talk about modulation technique, so
yes.
what is basically a narrow difference between the modulation format and modulation technique?
See this modulation technique like in the like ASK is it amplitude shift king, in which we
Mm-hmm.
can shift the amplitude, but in the
Mm-hmm.
format like that no return to zero. See
Mm-hmm.
this is non return to zero means it will not come to the zero, in which we can assign the signal like not return to zero. If it return to zero like that, one signal come like that, return to zero, then again come to zero, again come to that not. This is return to zero signal. So it is your design that from where you want to transfer your what is your format you can take. From here you can shift this return to zero sampling also you can shift these things. You can shift this phase also, you can shift this amplitude also, you can shift this frequency also that. But It is a format where you what format you want to transfer this analog signal to digital signal, and you can take any format like no return to zero, return to zero, and I think 3 to 4 format. I forget that. Jonah, can you have you remember?
And Manchester, sir,
Yes,
Manchester,
yes,
AMI,
yes.
AMI modulation format.
Yes, so you have to take the advantage and disadvantage of that format, which is best format for you and through which you can transmit the signal.
Okay, sir.
So if you have transfer only the 1 or 2 bit, you can take the BPSK PSK. But if you have this lot of bit like that, your data is more, then you can sample that in the 1 bit and you can transfer like that 16 QM, 64 QM, 8 PSK, 16 PSK. In that format, you can transfer that data.
Okay, sir.
Okay, so it
Okay,
is
sir.
your design through which you can transfer the data through analog digital. So you have to decide that which format you want to use.
Okay, sir.
So that's why you have to also know that what is the advantage of non-return zero over return zero. AMI, what is the advantage of the AMI over non-return zero? Okay, some format have a more signal to noise ratio, maybe power consumption ratio, or due to the shifting, some bit will maybe losses in the signal in that case. You
Okay, sir.
understand? Okay.
Okay,
So
sir.
anyone can explain more about these questions? Anyone from this? Kasturi, you have good answer. Very good. So I need more answer
Thank you,
on
sir.
this digital and all this signal. Anyone can elaborate more about these questions? Student, please participate. If you are wrong, no problem. But if you not speak, then how can I know that you have the doubt or you understand or not understand? You are 61 student and only one Kasturi will reply on these questions. At least 5 to 10 students will be. Otherwise, I will unmute and ask the questions.
Sir, I am unable to see the answers.
You are not saying my PPT is not visible?
So PPT is visible, but you are saying that Kasturi has given the answer, but I'm unable to see the answer.
No, no, he just speak. You know,
Okay, okay, okay.
you answer me that which statement is correct and why, incorrect or why, in this four.
Okay, okay. Okay, sir. Okay, sir. Okay, sir.
So you can answer anyone that A is wrong, B is wrong. I know. Do not need that you answer the whole the 4 options, but whatever you know, you can reply on that.
Hello.
Yes.
Yeah, D
Kusa-
option is wrong because in FSK it's very difficult to switch optical frequencies. That's why we hardly use FSK in modulation techniques.
So, but it has some advantage over that BPSK and QPSK and everything.
The advantage is that can be like in BPSK or QPSK, these are more noise resilient systems.
So,
FSK might be less noise resilient as compared to these modulation formats.
so why not we use the FSK? Then we have to
We
use that. We need a less signal to noise ratio, no? If noise will be less, then we will get the
because
accurate signal from our receiver side.
the main disadvantage is that in FSK we use two carrier frequencies
Yes.
for for 1 and 0, but
Yeah.
it's difficult to switch the carriers between 1 and 0. That's why we don't use FSK.
Okay.
It's very difficult.
Okay. Okay.
Like
Good.
in
Good.
intensity modulation, it's comparatively easy as we need to switch only currents between high and low. But
Okay.
to switch different frequencies, it's a difficult task.
But it has advantage of the bit rate also. It requires a less bandwidth.
Yes, this
FSK is required a less bandwidth, no? Than other signal. Other modulation that FSK required the same bandwidth. What are the frequency? It required only less bandwidth. Good, Gusagar, good. Anyone else? Namita, you have any answer?
So I found like C and D are incorrect because the A option is correct and B also is correct. That all the
Why?
natural signals are analog. So all the natural signals are analog in nature, like temperature, our temperature of the room, or weather is changing continuously at every instant of time. So it is that all the natural signals are analog in nature. So it is correct.
So your voice is analog or digital?
So it is analog. It is changing at every instant of the time. At
Yes.
every microsecond, it is analog in nature.
Oh, very good, very good. And what about the A? Digital communication require more processing than analog communication.
So in analog communication, we basically directly use modulation techniques, but for digital communication, we have to use for modulation format first. Then only we can move on to modulation technique.
Okay.
So that's why I think the digital modulation requires more processing as compared to the analog communication.
Good, good, Namita, good. Jayasri, are you here? Jayasri,
Yes, sir.
are you here?
Yes, sir.
So tell me about one that why, which is incorrect option in from these four, and why?
So, so according to me, FSK is widely used in optical communication is wrong, sir.
Why? Any justification?
So because we can't change frequencies for optical frequencies, sir. It requires more
No, no. If you have a single
electron.
mode fiber, you can send the single frequency also there.
So we are using two frequencies, right, sir? Carrier frequency.
But one can you fix and second can be changed.
Yes, sir. For
It is not simultaneously you can change. It is not necessary that in FSK you change the two frequencies simultaneously.
sir, to carry the frequency, we have a carrier, right, sir?
Yes, we have the carrier edges. You are right. But why we not use in optical communication? Because it has the advantage. It requires a less bandwidth, so it will
Yes.
require a less space and it will go more pass through the fiber easily, and it will communicate more signal.
Sir, but it requires a complex circuit, I think, sir.
Yes, it have the complex, right?
That's why
Okay,
it is incorrect.
okay, yeah, okay. Any about other three option? Have you any idea?
No, sir. I can't understand the option C.
See
Explain
in
it,
the
please.
quadrature phase shifting system, he said that bit rate is always greater than or equal to the bit rate. So can you provide me difference between baud rate and bit rate? You know that how what is the difference between baud rate and bit rate?
So bitrate is product of baud rate and number of bits per baud.
Yes. So how can you define that? It is the just formula. And if you single language, you can if you there is a you're just like that a arts student or commerce student, you can ask how can you explain that? It is a technically you are correct.
Yes, sir.
So in QPSK system,
So combining two
how
bits.
much the signal we can send one time?
Sir,
In QPSK signal, in one symbol, how much bit will be there?
so four, sir, quadrature, sir.
It is four signal. Yeah, okay, right. So it will require the less baud rate or greater than bit rate.
Less, sir, less.
So it is correct or wrong?
Yes, sir, it is. The option C is incorrect, sir.
Okay, good, good. Rahul Motan. Rahul, are you here? Rahul. Rahul, are you here? Rohan Roy. Rohan. Rohan. So I have explained the first option that digital communication is more processing than analog communication. The reason is first is the bandwidth, second is the power requirement, third is the fidelity, four is the hardware flexibility, five is the error rate, six is the synchronization, and seventh is the cost. Okay, so digital communication equipment are more costly than analog communications, and it require more bandwidth for transmission. So in digital communication, we bandwidth equal to 2 FM maximum frequency, but in analog case we transmit the signal like that bandwidth equal to FM also that. So it required a more costly, more bandwidth requirement, more power requirement. So it is more processing than analog communication. That is the reason. If you have any doubt in this reason, then you can ask me in this slide. If you not understand this 4-5 point I have mentioned, you can ask me. Second option is the Namita is also very good answer. He take the answer that good nature. He maybe explain. You can understand that also. Kasturi will be reply the good answer of that. So there is a no perfect generation of two digital signal in the real world natural phenomena. We like that I am speaking. It is also analog. Playing is also in analog form. Clapping is also analog form. So to convert this analog signal, we need a digital. Okay, because we require the less bandwidth, we require the efficient transmission of the signal. That's why we go to for the digital communication. Third is in QPX system, view rate is always greater than or equal to bit rate. So bit rate is the speed of data is expressed in bit per second. See, okay, all of you have answered the good answer correct in these things. So this is the view rate definitions. So I have given the one example also that if the symbol rate is 400 viewed and each symbol represent 2 bits, okay, then the translate into all of bit is 96 second bits per second, in which we have to multiply view rate with that bits. Bit rate equal to view rate into the number of symbol. It means it's 906,000 bits per second. It means view rate should be less than the bit rate. Okay, this is the correct answer. So this another answer is example is also I have explained that if any symbol, if n number of the bit per symbol, then the number of required symbol equal to s equal to n 2n, means how much number of the symbol required for transmitter of that signal. So it equal to 2n. So like that view rate into log 2s. So view rate into we have to convert this log 2 into 3.30 into log s. So if the view rate is equal to 4800 and there are 2 bit per symbol, then number of the symbol equal to 2 into 2 equal to 4. So bit rate equal to 9600 bit per second. It means we require a more bits rate than view rate, because viewed is in the form of the symbol. It will combine 4 signal or 2 signal into one sample and it will transfer per second. But we divide in bits. Bits we have to transmit one by one, like that one. This is 1, first transmit this 1, then this 0 will transmit, then again this 1 will transmit. But in the view date like that 101, 01, 01, this 4 signal will be, this packet will be transferred in 1 second. Okay, on the receiver side. That's why view date usually always be less than equal to bit rate. Next, like the frequency shifting key, all of you given the nearby the correct answer that there is a like a complexity. I also explained that to convert that in optical signal we need the encoder decoder. We have to translate this signal in the optical format. Like that I have amplitude on and high signal, and Jonak is also said that on off is more famous in optical domain. So next question is in 8 PSK modulation scheme the effective bit rate is. I need your answer now. I already explained you bit rate and view rate. So in I want to answer this. I already provide you the answer and some explanation. You can go through this PPT and please answer me one by one. I have not mentioned the correct answer. I need correct answer from your side. Guys, please involve in this discussion.
So 3 times the symbol rate.
Why?
2 power n by using
Okay, 2.2 की power.
n, sir.
Okay, so there is a 3 bit, 3 bit in one symbol.
Yes, sir.
So What is the? I need the bit rate. It is 3 times the symbol rate.
Yes, sir. Eight
So
bit rates.
yes, jazz option is 3 times the bit rate. Anyone else? Otherwise, I will take the name and you should be answer that. Please, guys, involve. Kabir Das, are you here? Kabir. Kabir, are you listening this session or you have just joined and left that? Kabir. Deepak Singh.
Yes, sir. This is Kabir Das.
Yes?
Yes, Kabir Das, sir.
Double? Yeah, Kabir
Yes,
Das.
sir. Three
Please,
times
please.
the symbol rate is the correct answer, sir.
3 times the symbol rate.
Actually, as previously we discussed, bit rate is equal to baud rate multiplied by the number of bits per baud rate.
So how much the symbol in this 8 PSK?
In 8 PSK, each symbol is grouped into 3 bits. 3
Okay,
bits
group.
are required per symbol.
Okay.
So,
So,
three times
so
the baud.
what you understand from these two diagrams I have mentioned in below that? Can you explain with these two diagrams if you understand? You will join the lecture and that. I have mentioned also that in that paragraph that A B C D E F G H.
Yes, sir.
So what is
It
the
is
PSK? Can you explain the PSK?
PSK means phase shift keying. That means
So
for every bit change, there is a phase is shifting. For example, one bit is changing from 1 to 0, then phase is changing from like 0 to pi, like that.
okay, 0 to pi. So we
In
can
case of
invert.
BTS, binary case, I am telling.
Oh yes, yes, I understand that.
Hmm.
Okay, okay. So what is the type of the digital modulation? Can you explain me about how much digital modulation existing? What type of the digital modulation? One is the PSK. Can you explain me?
Yes, sir. Other one is ASK is their amplitude shift keying. It is also called OVK. And other one is FSK, frequency shift keying. We can use QAM, both quadrature phase and amplitude both simultaneously changing.
So can you explain which signal require more bandwidth in this ASK, FSK, PSK? Who will require more bandwidth? Which modulation require more bandwidth and more power?
I think PSK requires more bandwidth.
Why?
Why exactly I don't know, sir. But as you discussed previously, FSK has less bandwidth.
Yes,
Based on that,
FSK is less bandwidth,
based on that, I am telling.
but ASK required more bandwidth in that case.
Okay, okay, sir.
Okay.
Okay, sir. Understood.
We have to ASK is, that's why we use not the ASK. Every time people will be using a PSK or FSK in digital communication.
Okay, sir.
Okay, okay, Kabir.
Okay,
Ajay
sir.
Sharma is here. Ajay, Ajay, are you here? Lakshita Puli, Lakshita, Lakshita, are you in the class? Neha, Neha, Pooja, Pooja, are you there? Pooja, Rajeshwari. No one is there. Are you only just join and leave that class? So next question is, which of the following statement is are incorrect in relation to sampling and quantization of the analog signal? I have already provided you below the answer. I need the reason of this. Why two are incorrect and A and D are correct? B and C are incorrect and A and D are incorrect. I need a reason from your side. Whatever you can, please answer that. If it is incorrect, then I will correct it. But you have to speak. Please. I think only 10 to 12 students are listening, and other will just join and left that meeting.
Sir,
Yes.
sir, if you take x-axis amplitude will quantize, sir.
What is x-axis?
Amplitude will quantize, no, sir. Sampling term will say quantization will done on amplitude.
Okay.
That's why I think first question is correct. Option A is correct.
Okay.
Why
It
is-
means option A is incorrect. In this way, x-axis is discriminant in quantization. Means
No,
it
no,
will
sir.
in the
I'm
it
saying
will
about
quantize in the
amplitude.
sampling.
Sir,
You said that option is A is incorrect or correct?
correct, sir. My
Correct.
my question. No, sir. I'm saying amplitude will be quantized, no, sir.
Okay.
Why if sampling is done after quantization, we will quantize on amplitude. No, x-axis will quantize, right?
Okay. What about the other? You have any knowledge about other B and C and D?
Where y-axis is created.
Anyone other?
So option C is correct because we are always assigning one, like for two level, we are assigning values like 0001 1011. So I think option C is correct one.
Okay.
According to that, like I'm taking about two level, 2.6 level. So we are assigning values 00. Like if we are taking sample values from 0 to 1, it comes under 00. For like 1 to 2, it comes under 0 to 01.
Okay.
So option C is correct.
Okay. Okay. Good. Good, Namita. Anyone other? Any other, please? Sunil Prajapat.
Yes,
Sir,
sir.
answer D is incorrect
Answer D is incorrect. Why?
because as number of quantization levels increases, we need more number of bits to encode. So
Okay.
as number of bits increases, obviously bit rate increases.
Okay. So what is the relation between that number of the quantization and bit rate?
Is equal to 2 to the power n.
Okay.
If I'm not wrong.
Yes.
So I have already provided bit rate equal to fs into log 2n.
Yes. Yes.
Yes, sir.
Okay.
Yes, sir.
So fs is here. Fs is what?
Sampling frequency.
Sampling frequency.
Okay, sampling frequency. So have you heard about the Nyquist rate?
Fs is equal to 2 FM.
Maximum frequency.
So why do we need the sampling in the digital communication? Why we need a sampling and quantization in the digital communication? Can you answer me?
Sir, to convert the analog signal into digital signal, sir.
What?
To convert analog signal into digital signal, we need sampling and quantization. Sir.
So if my signal is like that,
Sir, my question.
this is my
answer
analog
is-
signal.
Yeah,
One-
analog it will be continuous, sir. In digital it will be discrete manner, sir. For this we are using a sampling technique, sir. Analog it will be continuous pattern. In digital we will discrete in particular value,
So
value.
so if I do not do sampling, then what happen?
It will be continuous nature, no, sir. Integrating it will be
No,
continuous.
I have converted my analog signal into digital signal, and if I do not do the sampling of that signal, then what happen in that case?
So for every like for every fraction of second, like the signal is changing at every instant of second. So
Okay.
if we are not doing the sampling and quantization, we have to take each minute level.
Okay.
So this is the main disadvantages. Like we are like for 0 to 1, we are taking putting value like 00. If any signal in the range of 0 to 1, we are assigning the value 00. If we are
Okay.
not doing that, then we have to take very large numbers of samples.
Okay, we have to take the large of sample. If we take the large of sample, then what happen?
So system complexity will increase.
Yes.
If we take large number of samples, system
Bandwidth
complexity
increases.
will get increased.
Bandwidth increase. But one more things that more important in the signal system is that in communication is that loss of that signal. If
Yes.
you know the aliasing effect,
Aliasing effect. So I know, but
If the
right
signal is
now,
undersampled,
Interference, no, sir.
yeah.
if we aliasing effect means loss of the signal, we have lost some data in that case. If our sampling frequency not greater than the 2 FM, it means some signal will be lost in that case. Some
Yes,
some
sir.
some signal have the low frequency, some signal have the high frequency. You Namita, you're right that we have to sample that in average case. In that case, we cannot sample bit by bit or every bit we cannot sample. So we take the average and we have to sample like the flat top sampling. 2 to 3 type of sampling is there. We use anyone that.
Yes, sir.
Or if we do not do the sampling, it means loss of the signal. There is a aliasing effect in there.
Yes, sir.
Okay, so
Yes,
we
sir.
have to
Yes,
do
sir.
sample, and quantization means we have to assign some level of that signal, like that our signal is from 0 to 1 volt. Okay, so we have quantization means like that this is step size quantization, gradual size quantization, step size quantization will be like that. So we have to like that this from this value to this value we like that we assign to delta 1, from this value to this value signal amplitude we assign delta 2, from this value to this we have to assign the delta 3. So we have assigned one value to that average of that signal.
Step size.
Step size we have to assign that in quantization mode. Okay.
Yes, sir.
Uniform quantities. Sir, for non-uniform it would be changed, no, sir.
So we have to use the granular case in that we have two mode of that quantization. You have the two mode of the quantization. Whatever you can use that, it's depend upon your sample frequency and sample type or whatever the bit or data you can transfer that. So why we use the sampling is done period to the quantization process? Anyone can answer that? It is correct option, and why? Why we have to do the sampling?
Sir, sir, we'll sample, sir. After that, we'll quantize, no, sir. We'll equalize that value to a particular value through quantization.
Yes,
Through
yes.
y-axis, if you see, for example, it is approximately it would be like if you see sinusoidal signal, it would be like what do you say, sir? From peak to zero, it will be rise, no, sir. At that time, if you take through quantization, we equalize the value, sir, through x-axis, y-axis.
Okay, okay, okay. Anyone
From
else from this?
attenuation should be low.
What, Maniji?
Attenuation should be low.
Yes, yes. Good, good. Any else? Anyone else? I need from all the participants. Please, who are not speak, please speak one time.
See, more is the quantization, more propagation of the signal.
So there is the quantization error. Maniji, can you explain that quantization error?
See, quantization error is basically if we are going to sampling and quantization, then loss will be less. Means attenuation should be less.
Okay.
That's why we are doing. See, ultimately, why we are using the digitization, because of the in case of analog signal, there is losses are there.
Yes, yes.
So that's the only reason we guys are using basically this digitization of the sampling signals.
Okay, okay. So if the quantization like that, my step size is delta. So how much the quantization is depend upon step size? Any relation you can know if you have any period knowledge of that communication or that?
I think it's depend upon the bit rate.
Bit rate is 2 to the power n.
Absolutely.
Okay. So
Yep.
our delta should be like that. Errors step size like that. Error equal to delta square upon 2 to the power n. Maybe I am also maybe wrong in this case. I verify that, but as per that, my knowledge it is delta square by 2 to the power n. So if you anyone can know that, can correct me. Please, participant. Have you studied Shannon theorem in class?
Yes, sir.
What is this?
So Shannon theorem is it is related to capacity,
Yes.
and I think maybe it is somewhat it is B log to 1 plus S by N, if I'm not wrong. C is equal to B log 1 plus S by N.
Yes. So you from this theorem you can calculate the capacity of that channel. How much capacity that channel will be can carry the signal. Okay.
Yes, sir.
This is very popular theorem of the digital communication and it will come in every case here. So anyone about comment on this? Sarika Sharma? Sarika, are you there? Sarika? Sheikh Ruksana? Somyadeep Das? Tejender? Tejender, are you here? Rituraj Singh? Lakshmi? Lakshmi, are you here? Everyone joined the class and left that, I think that. They just joined for that, I think. Dr. Binu S. Dr. Binu. Deepak Singh. Ishita 337. Abhishek Kumar. No one is here. Huh? They just joined. I think they just joined for the attendance. I think that. We have the interaction class here because you have the less interaction with the course instructor. So we do the interaction. Whatever your doubt, we can feel that we can solve the problem both of together. Maybe I am wrong, you are right. In that case, I can help out in this your assignment, in your this paper, because this NPTEL course is very important for you. This designed by the ministry for you that to learn the more deeply about the subject from the IIT faculty. And if you are do like these things, I think that you just do for the certificate only. These people are who are not responding. So I think that you answer that sampling also very good. Analog to digital conversion is also like that. This coordination diagram that taking sample of XT at discrete quantization. Uh, so next question is last question is the number of the photon in pulse duration of 1 nanosecond at 1550 nanometer wavelength if the power is 1 milliwatt. So please solve it yourself and please type your answer in the chat box. I need everyone answer. You have the 5 minutes. Please, whoever there is a 44, I need a 44 response. Please, you have the 5 minutes and you can put your answer in that chat box. I will record that answer that and I will give the feedback to the instructor about you that. Please guys, if you are wrong, no problem. I will solve it for you. I will explain for you. If this class is not possible, next class we can do again that. It is for. I am happy to solve your doubt here.
Energy is equal to number of photons multiplied by energy of one photon.
So energy equal to?
Number of photons multiplied by energy of one photon.
Energy of one photon.
Yes. From this power and duration, we can calculate energy.
So energy equal to what is energy?
Energy is equal to, I think, power multiplied by time.
Nee, what is energy formula?
I think E is H lambda.
Energy equal to HF.
Photon energy is equal to h nu, hc by
Yeah,
lambda.
yes, it is as a Planck constant into frequency,
Yeah.
and frequency equal to
One
c.
photon,
Frequency equal to c lambda.
c by lambda.
Okay,
hc by lambda is the
okay,
photon energy.
okay. So please calculate. You are right, Kabir. Everyone, please calculate and answer. Please type your answer on the chat box. If you have a doubt, you can ask me. Please solve on the paper and type the answer. I need your answer. Please. Approximately you can count if you have the not calculator. In your mobile you have also calculator, scientific calculator. You give the approximation answer also, no problem for me. But I need the answer from your side. Abhishek, are you there?
Yes, sir.
Please solve. I already announced your name 3 to 4 times, but you not respond. Sheikh Ruksana. Jayashree, can you? Okay, Jayashree, very good. Please guide, please respond. Either it should be wrong or right, it is not issue. But you have to solve problem. If you left the meeting, it is just lost of you, not my. Guys, please respond. Okay, Kusagar answer is 7799. Okay, Deepak Singh left the meeting. Okay, Sunil is 2.3 into 10 की power 15. Guys, very easy. You have just multiply the energy HF and then you have just calculate that number of the photon and you divide by the duration. Power into that. Easy into power into the like that duration. It is very simple. You have given the lambda Planck constant equal to 6.626 into 10 की power minus 34 joule second. C equal to 3 into 10 की power 8 meter per second. You just put the value in that and you just calculate the energy and then you calculate that number of the photon n. This type question I also come your exam in a quiz. If you not solve here and if you not clear a doubt, how it is possible in that time? If it is wrong, it is not issue. Please respond. Namita, are you solving or you left? Namita?
Only, so actually, this is the time. Like I'm living in a family, so I have a kid also. So I'm just making food, so I'm unable to solve it right now.
No, no. It is only 2 minutes. Then we also finish that meeting also. That it is last question, please. You just type the idea also. It is okay for me. That not the whole calculation I need.
Okay, sir. Okay, sir. Okay, sir.
Okay.
Okay, sir. Okay, sir.
I know that you are the engineer and you are good in the calculation. I know everyone are mathematician. I need the idea
Okay.
behind that question. How to solve that approach? I need the approach.
Okay, sir.
Calculation may be mistake due to that typing and no problem. शेख रुखसाना, सुनील प्रजापत, तेजेंद्र, नागालक्ष्मी, मनमोहन, इंदू प्रिया, so Abhishek, how what is the meaning of that power we have given 1 milliwatt? How can you use that in this? If equal to n HV. Rishita, Ankita, Ankush, Devsri, Minakshi, no one have responded on in this session. Jagnathan, Jagannath Nayak, Kanika Sharma, Lakshmi.
Sir, I think like we should firstly convert this wavelength into frequency first.
Okay.
Like C is equal to F lambda.
Okay.
And so I don't know about like how to use the power formula for this. Like, I just really got like C is equal to F lambda. We have to convert this wavelength into frequency.
So E equal to what is this? E equal to n into photon. Okay, and then this is time. So you given the power, you calculate the n, you given the time, and you have to E. So this is missing for you.
See, first of all, the total number of photon is equal to the total energy divided by energy released by the single photon.
Yes.
So single photon energy is equal to hc upon lambda.
Yes.
So h is the Planck constant.
Yes, H is a Planck constant,
That is
6.626.
60 into 10 to the minus 34 joule.
Yes, yes.
And c is the
Speed of
wavelength
light.
the speed of light is 3 into 10 to the 8 meter per second.
Yes.
And lambda they are already given.
Yes.
So by virtue of which we can calculate the energy due to the single photon.
Okay, this is the Hc upon lambda E equal to.
Correct.
Okay. So if you
Yeah.
put that 6.626 into 10 की power minus 32 into 3 into 10 की power 8 upon lambda, you given the 550
5
into 10 की power minus 9.
Correct.
Okay.
Sir, can
So-
we substitute energy is equal to power into time?
Yes.
Then
We can get
total
energy
energy
that
is
is the minus
power
6
into
from
time.
Yes, yes.
So it will give the total
So
energy.
n equal to P into time into HV.
Correct.
So your
P into
answer will
time.
be 779,040.
Yep.
It is the correct
So-
answer. So Jayashree, very good. I think first answer is the Jayashree. It is approximately same answer. Jayashree, please clap for her. He maybe nearby he answer, and I think Abhishek is also write the same formula. Sunil is also write same things. So please, you have to solve this assignment yourself. I request everyone who are in the class who listen to me or who are not to listen to me. I will also request on the Google Classroom I have created. I need your actively participant. You can put your doubt on the Google Classroom also for me before in whole the week. So I will prepare your doubt on that this live session also. So I request to, if you have any doubt during the ma'am lectures, you can put your comment on the Google Classroom also. Everyone has joined the Google Classroom? Guys, you
Yes,
have
yes,
joined
yes.
that Google Classroom?
Yes, yes.
So you can put your doubt also there. You can mention that this video or this slide we need a more clarification. I have already shared like that Google Classroom link and Google Meet link, both of you. So
So I have one doubt.
yeah,
So just give me one like trick or something like that so that we can easily remember, frequency and wavelength for
yeah,
any frequency range like microwave, optical fiber,
okay,
whatever it is. Like we used to forget.
okay,
Like we always every time we have to cram the things. Is there
okay.
any way out so that we can remember easily microwave frequencies or optical frequencies like in nanometer and as well as in hertz also?
Like that we have the light band band diagram. Okay, so we have
Okay,
the
sir.
so if we I take the one new slide. I can take this slide. Like this.
Are you making it right now?
Yes, I am making it.
Okay, okay, sir. Okay, sir.
So like that, this is the spectrum of the light, whole spectrum. Okay, so I
Okay, sir.
divide into 3 to 4 portion like that.
Okay.
So, okay, so first is my UV band, then my come to visible band, then my IR, and then far IR. Okay,
Okay, sir.
so whatever that UV band is from that like that from 100 nanometer to 400 nanometer, like the 395 nanometer or 400 nanometer. Okay,
Okay.
and visible range, in visible we have the like that Vibgyor spectrum, hold the Vibgyor violet to red. Okay, so in visible we have the Vibgyor spectrum, violet, blue, green, orange, yellow, red. Okay, so it range will be from 400 nanometer to 700 nanometer. Okay, hello,
Yes,
you
sir.
will,
Yes, sir. I'm listening, sir.
okay, so from 4 to around 450 we have the violet region. After that we 450 to 480 like that way blue region. So in this type red region will be below come from 650 nanometer, last red region, red color. In IR we given from 700 to 1100 nanometer in the IR region. So you ask that how can we about that theta region, theta hertz, and that you have to remember that. So we have that frequency equal to C lambda. Okay, you
Yes,
understand
sir.
this formula? This is the
Yes, sir.
this is the universal constant 3 into 10 to the power 8. Okay, so if you know that my frequency is in the theta hertz formula like that 1 terahertz, it is microwave frequency. It is microwave band. Terahertz is in microwave band. Okay, like that in terahertz means 10 की power 12 hertz. You understand?
Yes, sir. Yes, sir.
If we have the penta या theta terahertz, penta means 10 की power 15 hertz. Okay, you understand?
Yes, sir. Yes, sir.
You know the basic scale like that. If we 1 centimeter equal to 10 mm, you know that.
Yes, sir. Yes, sir.
Okay, like that in frequency we are move like that. Frequency hertz, kilohertz, and megahertz, terahertz, theta hertz. तो hertz तो normal hertz is like that 1 centimeter. Kilohertz मतलब kilo, you know that kilo, how much kilo? If you buy
10
the
to the power, 10 to the power 3.
yes, if you buy the 1000 gram of sugar means 10 की power 3. Mega means 10 ki power 6.
Yes, sir.
Terahertz means 10 ki power 12, and one is 10 ki power 9 hertz also. That I forget that. Uh, Maybe I. Can you anyone remember that 10 ki power 9 hertz means? Nanohertz we cannot say that.
10 to the power 9 is gigahertz, sir.
Gigahertz,
1
gigahertz. Oh
gigahertz.
yes, sorry, gigahertz. Okay,
Gigahertz.
okay, and then we have to femtohertz means 10 ki power 15 hertz.
Okay, sir.
Okay, so you
Yes, sir.
just simply you can correlate this frequency with your basic scale. So you can remember easily, or you can, if you forget, if you have the lambda, you know that IR range is 700 nanometer, you can put your 700 nanometer, your 3 power, you can directly calculate the frequency. So it will remain in the IR range, in the terahertz range, or far infrared range, you can remember that.
So thank you so much, sir. You are making it like very easier now. It is I was able to remember this thing.
Okay,
Thank you
so
so much,
in
sir.
optical communication, we use the terahertz only. Okay, we frequency in the terahertz, we always in the microwave and optical, we go the beyond the IR range and that. Okay,
Yes, sir. So
so
in microwave, we are in optical, we are using 10 to the power 13 to 10 to the power 16 hertz, no?
yes, so it is the terahertz to the femtohertz.
Yes, sir.
Okay,
Yes, sir.
so because the lambda frequency is directly proportional to the speed of wavelength. If more frequency will be, then it will travel more distance. It means you require the less lambda. Okay, so
Yes,
yeah,
sir.
if your light wavelength is less, then it will have more frequency and it travel with more fast. It is the common basic mechanism of the optical. If you want to travel a signal through the optical fiber, and if your wavelength will be less, then it will have the more frequency, sampling frequency, and it will travel equal to fast because it is directly proportional to the speed of light. Okay, Namita,
Yes, sir.
understand?
Yes, sir. Yes, sir.
So in chat box I put the Google Classroom link again. Please join that Google Classroom also that. So you can put your doubt here. So I can prepare according to next week class live session 2 class, and in live 2 session class I will include assignment 2 as well as your doubt. Whatever the put your 7 days in the Google Classroom, I will include all the doubt. So please read and ask me maximum questions. I will hear for the solution for your doubt.
Sir,
If
is it possible? Is it possible to either shift the timing between 9 to 5 or somewhat like weekend? If, is it possible?
Namita,
In weekend,
actually,
we can adjust for 7 to 8 also, but 9 to 5 we are in office and afterwards like it is very difficult.
I understand Namita, but I will put the request to the NPTEL team. If they will change the timing, then I will happy with that. I have no issue. I need your
Okay.
maximum participant in the class. If everyone will be happy, then in the Google Classroom you can comment that we are. You can also suggest that timing, and everyone can comment on that timing. Then I will finalize that timing. But after the 5 o'clock, I will take the class because I have also that my PhD, and I have to do the my research work also. That
Okay, sir.
Yeah,
okay.
basically because we are in the academic setting, we don't have any sense of timing. So like after this, I have to go take a printer for tomorrow. We have an exam. So like we have no sense of time. So 7 to 8 doesn't make any uh, like in work hours we have classes. That's why we have to do it outside of work hours. But of course, 7 to 8 can be changed to like 5 to 6 or 6 to 7 maybe.
Yes, we
Something
can
can be
No,
put.
done.
sir. Then 7 to 8 is fine. 5 to 6, 6 to 5, 7.
No,
Like it
no,
was like
we can put that, but I need a maximum because if there is like 70 to 100 students are registered in the course, and for that I need every student concern on that also. If everyone is okay with that weekend, then I will take also class weekend, no problem from my side. I will put the request to the NPL team.
Also,
okay,
are
sir.
you guys accessing the MATLAB licenses that NPTEL has provided? Like, there is a MATLAB section in the course page, I think. You might want to use it when you can. I'll show codes when possible. Like today, Sunil asked something about why don't we use like negative SNR values. So I had a simulation, but he has left. Also, it's getting late, so maybe I'll show next time or something.
Yes, Jonah, I think that in the classroom, that in course, there you have put the link of MATLAB also.
Yeah, so like if you want to, you can make use of that. Like
Yes,
MATLAB
yes.
team has collaborated with NPTEL to provide you the licenses. So like try it out at least.
So, any doubt, any students, or can we conclude that this session? Okay, thank you so much. We will meet on next Tuesday again. So please put your doubt on that Google Classroom. So I will take all the doubts, and next we have to discuss the assignment second. Thank you so much.
Thank you, sir. Thank you so much.
Thank
Thank you,
you.
sir.
Thank you. I actively participate. Next time I need all the participants should be participant in this discussion. I hope that everyone understand, and they will ask the doubt and participate in this. Okay, thank you.
Thank you. Thank you.
Thank